The standard model's internal symmetry is incredibly successful. The behavior of particles aligns with an exact mathematical symmetry, SU3, SU2, U1. But there is a glaring omission in how this 12-dimensional Lie algebra is used in modern physics. It enters our equations as an assumed structural input. We start by plugging it in, rather than deriving it from the physical universe itself. This leaves us with a massive theoretical gap. We know this specific mathematical structure works to organize observed gauge interactions. We do not know why nature chose these precise representation dimensions, or why the particles exhibit the exact rational charge assignments they do. Can this exact algebraic structure be deduced directly from the underlying geometric rules of the universe? Accepting this mathematics simply because it works forces us to memorize the shape of reality without understanding its origin. Without a geometric anchor, our understanding of physics remains incomplete. To find that anchor, we turn to the TCGS-SEQUENTION framework, a geometric architecture that reorganizes the relationship between mathematics and physical space. Up top is counterspace, a complete four-dimensional source manifold. Below is the shadow, our observable universe, projecting the events in counterspace. Within counterspace, a conserved point, the distinguished singular origin, P0, anchors the entire system, containing all the data required to generate physical structures. How that data becomes readable in our shadow universe is governed strictly by the extrinsic constitutive law, or ECL. The ECL is the definitive mathematical response law, dictating how signals radiate outward from the P0 origin. When the ECL projects reality outward, certain symmetries are perfectly preserved. We call this the residual isotropy algebra, the mathematical structures that survive the translation. The standard model algebra is viewed here as the surviving symmetry of this singular origin point. Deriving that symmetry requires us to follow a strict rule for mathematical proof within this framework, known as the physical anchoring principle. As this statement outlines, representational capacity does not equal physical necessity. Finding a complex mathematical algebra with enough dimensions to fit known particle labels is a practice of accommodation. It is a mathematical fit, but it does not prove that the universe operates using that specific structure. The physical anchoring principle demands that any valid internal symmetry must emerge directly from the invariant data of the singular origin point and the extrinsic constitutive law. Every component must have a real physical expression. A true derivation relies on the geometry to do the work, rather than injecting algebraic rules to match existing particle data. To see how strict this principle is, let's test 3 intuitive geometric attempts to derive the standard model. Extracting the target algebra purely from the metric isotropy of a 4D source hits a mathematical wall. The algebra of ordinary 4D rotations yields exactly 6 dimensions. The standard model requires 12. 6 is too small to house the necessary symmetries. A second approach assumes that an isolated point singularity in 4D space automatically generates the topology needed for electromagnetism, specifically the U1 hypercharge. Topology disproves this. The integral cocohology of a punctured 4D sphere evaluates to 0. A bare point singularity lacks the non-trivial bulk U1 topology required for the standard model. The third approach points out that a 4D space naturally possesses a 16-component exterior form carrier, providing enough mathematical room for the necessary fields. While true, 16 components do not force a unique physical interpretation. This dimension does not select a specific mathematical grading or multiplication law over any other. Bare spatial geometry is structurally insufficient. The specific response generated by the extrinsic constitutive law is required to filter the mathematical possibilities. This leads to Theorem 7.1, the singular origin block stabilizer, which isolates the exact mathematical conditions required to recover the standard model. The ECL response generates protected blocks of dimensions 3, 2, 1, and a singular source line. Applying common source trace coherence forces a single functional across these blocks. This restriction reduces the algebra directly to SU3, SU2, and U1, yielding the exact empirical hypercharge coefficients. The dimensions of these protected source blocks dictate the specific fractional charges observed in particle physics. Physicist C. Fury has demonstrated a mathematical realization of this exact algebraic pattern using a nested chain of division algebras, reals, complex numbers, quaternions, and octonions. The TCGS-SEQUENTION framework interprets these results through a different lens. In this system, those division algebras serve as a normal form. They are an elegant descriptive language for the surviving symmetries, rather than the fundamental physical source. The physical anchor remains the 4D Riemannian geometry and the singular origin point. We can elegantly read the observable output using these division algebras without ever requiring them to construct the fundamental physics. The geometry provides the physical necessity. The algebra provides the classification. We now have a pipeline that tracks how geometry dictates observable reality. Following this flowchart, invariant data starts at the P0 origin, radiates through the ECL response operator, is filtered by the trace coherence condition, and appears as particle data in the shadow readout. This establishes a methodology for geometric derivation, replacing post hoc fitting. Under this framework, every component of the standard model gauge has a definable geometric anchor in counterspace. The mathematical beauty we observe in the universe is the result of these strict geometric constraints. It is important to state the current limits of this work. Theorem 7.1 is a conditional mathematical proof, not yet a completed particle theory. A gap exists in the trace coherence condition. Currently, this equal weighting is selected because it produces known charge ratios, but it has not yet been derived organically from the source equations. This makes the framework falsifiable. It specifies exactly what must be proven or rejected to validate the theory. The next requirement is to compute the ECL spectrum from the source equations, proving nature generates those exact 3, 2, and 1 dimensional blocks. The structural map for a geometric derivation of the standard model exists. Whether the universe populates that map depends on the results of those final spectral calculations.